So I'm going over section 5.2 today, the definite integral. I'm going to start off by doing the problem statement. Evaluate the integral. My assumption is going to be none because the numbers don't really change. Formulation, I wrote out the problem and I defined every aspect of the problem. So this right here is the definite integral. 3 and 1 are the lower and upper limits of integration. As you can see, 3 is on the upper integration. That's because it is higher. This right here, whatever is inside of my lower and upper limits of integration is going to be the integrand. The integrand is what we differentiate. And d of y is what you see right here. That's gonna be my differentiation value. All right. I'm doing problem 40 on page 400. So to start off, I will use the general antiderivative rule on the integrand. In this case, the integrand is given to me like this. So y3 minus 2y squared minus y over y squared. So in this case, I would just square all of them by y squared. And I'll get y minus 2 minus 1 over y dy. From this, I would then use the general antiderivative rule found on page 381 to find my answer. So after using the general antiderivative rule, I'll get y over 2 squared minus 2y minus ln y. And then from there, I'll use my limits of integration to evaluate. So 3 and 1, I'll plug 3 into y, and then I'll plug the 1 into y, and then using the fundamental theorem of calculus on page 392, part 2, I will subtract 3 minus 1 to get an overall answer. And from this, from the fundamental theorem of calculus, I'll get is equal to negative natural log 3. Thank you. That's my presentation. And for all my mathematical lovers out there, this is how you find it and evaluate it on Mathematica.